Hello, students. All right, so we are going to look at special right triangles right now. As you can tell, we have a screen within a screen. It's very Inception-esque. That is because I recorded it before and it did not work. So I'm going to record the audio now. Let's try this. There we go. All right. So special right triangles, you did a do now on this. Now we're looking at triangles. They're special because they have these different properties that we see over and over and over again. So you already did a practice on this, but now we're actually going to put it in our notes. So on your paper, you may draw these two shapes. They're the ones that you worked with already. This one on the left is a 45, 45, 90 because it's an isosceles. The one on the right is a 30, 60, 90. And in your drawing, you can add the labels to the sides. So we have a 90-degree angle, we have 45 degrees and 45 degrees. And what we know about this from our pattern is that always we had it as 45, 45, 90. So that's just a way that we call these triangles. So we call this one 45, 45, 90 because of its angles. And the other one you saw was 30, 60, 90. So crazy idea, but we're going to call that one a 30, 60, 90. The 60 degrees is the larger of the acute angles, and so on. All right, so you noticed a pattern as you kept going. You noticed that the side lengths of the 45, 45 degree triangle of the legs had to be congruent. So we can show that with those two congruent symbols, and we also labeled them the same way. So you notice these patterns. We're not going to show a bunch of examples, but you notice that both of those legs, if we call them x, then our hypotenuse always ended up to be x times the square root of 2. Now, if x was a whole number like 4, then our legs were both 4 and our hypotenuse was 4 square root of 2. But we're going to look at an example where it's not, where it isn't always going to have a hypotenuse of 4 square root of 2. Now, for the 30, 60, 90, our shorter leg was always x. And we knew, based on that from our pattern, that our hypotenuse was always double that. So we would say 2x. And then our longer leg would end up being x times the square root of 3. And that was a pattern that we noticed also. So if the shorter leg on that side was, just kidding, I'm talking over here. All right, so we notice our x's, our x squared of 2. So let's do a little example. You don't have to write this one. I'm going to write it in red. So you don't have to write this little one that I'm going to write. But if we had x was 4, so we'd have 4 squared plus 4 squared equals c squared. We're going to just go through that example. So we get 16 plus 16 equals our hypotenuse squared, which is 32. So we'll take the square root of both sides. When we take the square root of both sides, we get a positive or negative, really. But because we're looking at a distance, we'll only worry about the positive square root of 32. So let's make our tree. We get 16 times 2. 16 breaks up, and we can keep going on our tree. You're writing this, or you don't have to write this in your notes, but you'll notice we got 2 times 2, which is 4, and then we have a 2 left over, so we get 4 square root of 2. So it worked for that example. And because we saw that over and over and over again, that's why we get to use it. So today we'll look at some examples that are less common, that are more of the tricky ones for people, but we're still going to use this basic idea in order to help us. So in your notebooks, you may draw some more triangles that look like these. All right, so this one we have a 45, 45, 90 triangle on the left, a 30, 60, 90 triangle on the right. And we're going to show some work with these, so if you want to leave more space around them, that would be good. So on the left, you'll label each of the sides. If we know it's an isosceles, we know that the angles have to be 45. So let's say that our hypotenuse let's say that our hypotenuse is a number. We're going to choose 10. Or we're going to pause at 10. We'll get there. There we go. And it's 10. All right. So notice how our 10 is our hypotenuse. Well, the hypotenuse is also equal to x times the square root of 3. Whoops, that wasn't the right thing to do. All right, so I'm just trying to acknowledge to you that our hypotenuse, x squared root of 2, is the same as where 10 is. So those are located in the same space. So because that, they must be equal to each other. So we can actually do that. We can set them equal. And now we can solve for x. And when we solve for x, we'll actually end up with the side lengths of the legs. So how do we undo multiplying by square root of 2? Well, we divide by the square root of 2. So we divide both sides, those cancel, and I'm going to switch the sides around, I believe. So we get x equals 10 over square root of 2. And now, you guessed it, we're going to rationalize that denominator, bringing back the principles of math skills. Good, so we multiply top and bottom by square root of 2. We will end up with 10 times the square root of 2 over the square root of 2 times square root of 2, which would be the square root of 4. And we can simplify this further. The square root of 4 we know is 2. Very good. And then you notice we can simplify this further. So those constants, the 10 and the 2, we can reduce those. Now sometimes on the numerator we'll get an odd number that won't be divisible by a 2, and you would just leave it as a fraction. But in this case we can reduce it to 5 square root of 2. So that is what the length is for each of the legs. So this leg is 5 square root of 2, the other leg is 5 square root of 2. And both of them are 5 square root of 2. I'm going to erase this just for convenience sake on writing on the next question here. Good, so let's try a 30, 60, 90 triangle. An example for this one. So let's label our picture just enough at least. Create a little space, so we've got a 90-degree angle. The larger interior angle is 60 degrees, and let's say our long leg is 6. And we want to solve for x and y. Now notice how 6 is on the longer leg. If we go, and it's across from the 60-degree angle. So if we go up to our example, the longer leg is x times the square root of 3, and that is also opposite of the 60-degree angle. So we can set our 6 equal to that longer leg side, so equal to x times the square root of 3. And now we'll follow similar steps that we did before. So we need to get x by itself. And notice how our x's are in the same place, so we're still solving for x. So we'll divide both sides by square root of 3. And you guessed it, we're going to rationalize that denominator again. So 6 over square root of 3 will multiply by square root of 3 over square root of 3. And we get square root of 3 times square root of 3 is square root of 9, which is 3 equals x. And then we can simplify again. So 6 over 3 is 2 times the square root of 3. So we just rationalized that denominator. That was a step that we did not show there. And we notice that that is what our x equals. That's a shorter leg. And we know that our shorter leg, if we multiply it by 2, we'll get our hypotenuse. So we want to solve for y using our shorter leg. We know that y is equal to 2x. We know what x is, so we need to figure out what 2x is using our x. Okay, so we're going to set y equal to 2x. And then we know what our x is, so we're going to do 2 times the square root of 3. And we can multiply our constants here, not the radical, but the 2 and 2. So we end up with y equals 4 times the square root of 3. And those are our answers. So you'll get to use the rest of the time to work on the practice. Oh, here's a whole lot of stuff. All right, I will see you soon. Bye.